Okay, hello, welcome once again to another series of teaching based on the chemistry jam syllabus. And today we are going to be looking at oxidation and reduction. I remain your tutor, Anjorin Oluwafemi Excel. I hold a BS in chemistry and a postgraduate diploma in education, science education to be precise, and a master's in environmental and analytical chemistry. Today we are going to be looking at oxidation and reduction. We just call it Redox for short. Our learning objective for this particular topic is as follows. Just a minute, please. Okay, so it is expected that by the end of this lesson, students should be able to, one, define oxidation and reduction in terms of electron transfer, addition slash removal of oxygen and nitrogen, then changes in oxidation state. It is also expected that you should be able to identify oxidizing and reducing agents in chemical reactions. By the end of this lesson, it's expected that you should be able to assign oxidation numbers to elements and compounds and reactions using standard rules. It's also expected that you should be able to differentiate between redox and non-redox reactions using changes in oxidation state. Okay. It's also expected that you should be able to balance redox reaction in acidic and basic media using the half reaction oxidation number method. Okay. It's also expected that you should be able to apply IUPAC naming based on oxidation states to write correct compound names. Okay. And to demonstrate laboratory. So we start off with definition of redox itself, oxidation and reduction, which we refer to as redox. An oxidation reduction reaction is a type of chemical reaction that involves a transfer of electron or transfer of electrons between two species. And that's what oxidation reduction is all about. We can also say that an oxidation reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. Okay. So those are two very good definitions that we can use to describe oxidation reduction reaction. Okay, we must also take note that oxidation reduction reaction is not just limited to the lab, but it is common and vital to some of the basic functions of life that we can see around us. Example, photosynthesis, we can see redox reaction or oxidation reaction, oxidation reduction reaction taking place in respiration also, which is a very, very important part of cell life. Is redox reaction is also featured, it can also be seen in combustion and corrosion or rusting. We can also see oxidation redox reaction taking place, in those systems or those examples that we've stated. Okay. Having said that, let's try to define oxidation and reduction itself. And we're going to be defining based on certain criteria. The first one is in terms of oxygen and hydrogen. So in terms of oxygen and hydrogen, we can say that oxidation is the addition of oxygen to a substance or the removal of hydrogen. So oxidation is the addition of oxygen to a substance or the removal of hydrogen from a substance. That's in terms of oxygen and hydrogen now. We can equally say that reduction is the removal of oxygen from a substance or the addition of hydrogen. So reduction is the removal of oxygen from a substance or the addition of hydrogen. Okay. Let's look at examples to buttress this particular definition of oxidation and reduction. Now, the first one is looking at oxidation. Now, we say oxidation is the addition of oxygen. So when you have oxygen being added to carbon to give us carbon dioxide, that is an oxidation reaction. Oxidation has taken place. Secondly, reduction, we say, is the removal of oxygen. When you have copper 2 oxide reacting with hydrogen, hydrogen reduces copper 2 oxide to copper, and then it now have water being formed alongside. So that is a reduction because oxygen is being removed from what copper 2 oxide, and then it is being reduced to copper atom. Okay, now we now look at it as oxidation in terms of removal of hydrogen. Now, in terms of removal of hydrogen, we can use this example. When hydrogen sulfide reacts with chlorine, it will reduce, that is, hydrogen sulfide will be reduced to sulfur, and then HCl will be formed alongside. So what has happened is that there's a removal of hydrogen from hydrogen sulfide. So that is an oxidation. We say that the H2S has been oxidized to sulfur, so to speak, So that is what happened because it is a remover of hydrogen. Now, reduction we say is the remover is the addition of hydrogen. If that is the case, when you have a simple reaction like nitrogen reacting with hydrogen to give us ammonia. Now, what